today we are going to be looking at compound inequalities. We will still be solving our inequalities, but now our inequalities will be made up of two. Sometimes will be made up of two, and they will be a little bit more difficult. So today for your warm-up, what I want you to do is I want you to look at these two examples. So the first one is the freshman at Kearney High School must take a PE class or a health class. Whereas the second one says freshmen at Flores High School must take a PE class and a health class. So what I want you to do is write down on your paper, is I want you to highlight the differences between the and the or statements in these two questions. So as you can see in the first one, the freshmen at Kearney High School are required to take a PE class or a health class. But the freshmen at Flores High School must take a PE class and a health class. So I want you to write down, if Joe is a freshman at Kearney High School, will he take a PE class? I want you to write down your answer. If Joe is a freshman at Kearney High School, will he take a PE class? So hopefully you wrote down maybe. Joe could take a PE class, but is he required to? No. Because he has to take either a PE class or a health class. So since he's a freshman, he could have taken a health class. He could take a PE class, but he's not required to. Okay, now I want you to think about it this way. Darlene is a freshman at Flores High School. Will she take a PE class? Go ahead and write down your answer. Darlene is a freshman at Flores High School. Will she take a PE class? Hopefully this time you wrote down yes. Since Darlene goes to Flores High School, they are required to take a PE class and a health class at Flores. So no matter what, she will take both a PE class and a health class. So she is required to take both. Whereas Joe at Kearney was only required to take one. Make sure you have this written down. If you have questions, write them down and we'll discuss them tomorrow. Alright, what I want you to do is I want you to write down these three definitions. Go ahead and pause the video and write down these three definitions. So if you look at this, a compound inequality is two inequalities joined together by the word and or by the word or. So we have and or. So a conjunction is part of the compound inequality, but it's the specific name for the inequalities joined by the word and. Whereas disjunctions are part of the compound inequalities, but they're specifically the inequalities joined by the word or. So we're going to go ahead and look at an example of this. So we're going to look at this example. 3x is greater than or equal to 3, and x is less than or equal to 8. So what we remember from the last lesson is that since these are greater than or less than or equal to, they are including that value, so we represent that with a closed circle. So we need to write our list of numbers. We're going to start at 0. So now that we have our values, we're going to go ahead and graph. So x is greater than or equal to 3. So we're going to plot our number right here, 3. And we know that since x is greater, it's going to be anything greater. So we're going to start by drawing our line that way. However, we don't know how far it goes yet because we also have another value. So let's look at this. X is less than or equal to 8. So let's find 8. And we're going to go ahead and graph our closed circle since it's including 8. And it's everything less than 8. So our line has to go this way. Well, you can see that these two lines are facing each other. They're going towards each other. So that means we can connect them. So that means for this, and for an answer to be a solution to this inequality, it has value between 3 and 8. So that means it could be 3, 4, 5, 6, 7, or 8, or anything in between those numbers. Now let's look over here at an OR example. X is less than 5, or X is greater than 10. So once again, we're going to graph this. Alright, so we're going to plot our 2 points. So X is less than 5, so we're going to find 5. And look, since it's not greater than or equal to, our circle is going to be open. And we know that X is less than that, so our line is going to go that way. It's any value less than 5. We also have X is greater than 10. So we're going to put our open circle, and it's anything greater than 10. Since our lines do not go toward each other, we can extend them and draw our arrow, showing that they go on forever. In the OR case, our values go in the opposite direction, whereas our AND values went in the same direction. So with the AND example, our values of X are between those two values. But in our OR example, it's every number outside those. So it's anything less than 5 and greater than 10. ORs go in the opposite direction and goes towards each other. Make sure you have this written down. Alright, we're going to look at another example. We're going to graph this. X is greater than 3 and X is less than 7. Alright, so we're going to go ahead and plot our points. So I want you to go ahead and think about this for just a second. Look, thinking back to the example we just did, if you had to guess which way are our lines going to go, are they going to go in opposite directions or are they going to go towards each other? Think about that for just a second. Alright, well now we're going to figure it out. So X is greater than 3, so we're going to find 3. We have, it's not greater than or equal to, so we're going to have to represent that with an open circle. And then we have X is less than 7. So we're going to find 7, and that's also going to be represented with an open circle. So if X is greater than 3, that means X is anything bigger than 3. So we're going to represent that with our line. Over here, X is less than 7, so it's anything smaller than 7. So our values go towards each other, and they're representing with everything between 3 and 7, but not including 3 and 7. So hopefully you realize that with the AND, our values are going to go towards each other. Alright, now we're going to look at a little bit more complex inequality. Alright, so this one, it looks a little bit challenging, doesn't it? It looks a little intimidating. So instead of just going for it, we're going to break it up. So we're going to break it up into 2 inequalities. Since we have 2 of them, don't we? You see 2 inequality signs. So we're going to break it up into this inequality, and we're going to break it up into this inequality. So hopefully you can see that in the middle, the 6x minus 4 corresponds to both of the inequalities. So we're going to write these both down. So 2 is less than 6x minus 4. That's our first inequality. And our second inequality is 6x minus 4 is less than or equal to 14. Alright, so let's go back over here. We're going to solve it. We're going to add 4 to both sides. We have 6 is less than 6x. Divide by 6. So then hopefully you get 1 is less than x. And over here we're going to add 4. So we have 6x is less than or equal to 18. Divided by 6. X is less than or equal to 3. So now what you can do is you can put the 2 inequalities back together. So we have 2 separate inequalities, but since our inequality signs are both facing the same direction, we can put them back together. So we can say that 1 is less than x, which is what we got from here. And then we still have that x is less than or equal to 3, which is what we got from that part of the inequality. So our inequalities were combined at the beginning. This is a compound inequality, and we are combining them back together. So now we need to graph it. So let's draw our graph. And hopefully by now you guys can tell that when we say graph it, we are drawing a number line. So we're going to go ahead and draw some points in. Alright, so we have two numbers. We have a 1 and a 3. So let's find our 1. Our 1 is less than x. Well, knowing that it's just less than, we know our circle has to be open. And since 1 is less than that, that means the x values are anything greater than x. And then we have x is less than or equal to 3. Well, knowing that it's less than or equal to, it means our circle has to be closed. And we know that the x values are less than that. So then our solution would be anything between 1 and 3. Not including 1, but including 3. So that's how you solve that inequality. Alright, we're going to solve one more. So for this one, we have two separate inequalities. So we're just going to solve them as is. So we're going to add 3 to both sides. Divide by 4. And then x is less than 3. Over here, we're going to do the same thing. Add 4 to x is greater than or equal to 12. Divide by 2. So x is greater than or equal to 6. Now we're going to go ahead and graph our inequality. So we have a 3 and a 6, so we need to have points between that. Now that we have our points, we're going to go ahead and graph our two inequalities. So x is less than 3. Well, less than 3 means that our circle is going to be open. It's not including 3. And x is less than those values. So we're going to draw our line that way. And then we have x is greater than or equal to 6. So we're going to find 6. Since we know that it's greater than or equal to, we know our circle is going to be closed. And it's going to be all the values greater than that. So as you can see, that since it's an OR inequality, our lines are going to go in opposite directions, meaning that they don't touch, so we can draw our arrows going in the opposite direction. Alright, if you have any more questions over this, go ahead and write them down, and we will discuss them during the next class period.